Yeah, anyone to attempt the first question. Anyone who just has an idea on how to go about it.
Um, I have an idea, but I don't
You
know how
have
to
an
do it.
idea, but you don't know how to do it. Yes, you can give us the
Yes.
idea. We
Well, the idea is just on the values that are in the brackets. The line X there, I don't know how they do that thing. So I don't know.
okay. Mm,
We can do interrogation.
okay, but if you were to integrate it, what method were you going to use?
This one I would pray for a miracle way.
Okay, Doc Brandon has helped us. He's saying we can integrate by parts. We can integrate this using by parts. I hope all of us we are familiar with the general term when you are integrating by parts. Yes, one of the mnemonics that you use when picking the values, the U value, the one Doc was just written in the chat box. Do we all know the general form when we want to differentiate by Doc Moses is saying can't we use U substitution in here? Doc AG, can you use substitution work in here?
I'm not. I've never been a fan of this substitution, so for me it won't work.
For you it won't work.
Yeah, it might work,
That
but I don't. I think it will take time.
Doc Moses, did you try it? Okay. Okay, for me, I think that the best method that can work is the when you are integrating by parts. Yeah, that is the method I would go for. And I hope all of us we are familiar with the general term when you want to integrate using by parts. Anyone who is lost. Okay, so Doc Catherine, what's your hand is you have raised your hand. Okay, let me just do this. Docage, you give me the figures. We do it quickly. Just the general term. Docage, are you still in? Docs Lilo, you are still there?
Yes, I'm here.
Okay. Yeah, the general form for when you are dealing with when you want to integrate using the parts, you say the integral of u with respect to dv is equal to uv
Okay.
minus
This.
the
Mhm.
integ
Okay.
the integral of v with respect to du. This is our general term. This is our general equation when you want to divide when you want to integrate using parts. So what you do to pick your u, the first thing you need to do is to pick your u. When you are picking your u, you use the mnemonic let, meaning the a stands for logarithmic expressions, the a is arithmetic algebraic expressions, the t is for trig, and then the e is for exponential functions. So when we look at the questions that we have been given they are multiplying an algebraic expression and a logarithmic expression. So meaning that our priority for u is what? Is the x. So you say let u is equal to x. Are we together?
Following.
We are together. Oh, am I
Catherine is
audible?
saying. Catherine is
Am I
saying she's
audible?
lost. Yes, you are audible, but Catherine is saying she's lost. Where are you lost, Madam Kate?
At where is she lost? Okay. Oh.
Okay, you can continue. There is no response coming.
Okay, I was saying basically when you want to integrate when you want to integrate by parts, you have to use this general term here, whereby you say the integral of u with respect to dv is equal to u multiplied with v minus the integral of v du. Don't mind my integral symbol. It looks as if it's s. It's not s. Yeah. So when picking, the first thing you need to do is to pick u. So the mnemonic that you use to pick u is the let, meaning the logarithmic expressions. That is the first, okay, in order, the first priorities that you should take. In this case, we have been given an algebraic expression and then uh, a logarithmic expression. So I think I made a mistake. So what should be our u here? So our u here, our u must be equal to in x, is it x minus 2?
X plus 1.
X plus 1. Okay, thank you. So this is x plus 1. And then whatever is remaining else, what else is remaining? Docs Rilo.
There is X.
So whatever is remaining is what we consider to be our dv, which is x. That's all. It's just x. Okay.
dx.
X dx. So we have found our u, we have found our dv. So when you look at the general term, our equation, our formula, this is just like our formula. We have found our u, we have found our dv. What is remaining is for us to find the v, and what is remaining for us is to find the v and the du. So to get the du, you differentiate the u part. So if you want to get the du, you say dy dx du dx is equal to, you differentiate the in. When you differentiate in x plus 1, you are going to get 1 over x plus 2. So we have found our du. This is our du.
Where's the
No,
two
we are,
coming from?
oh, it's 1 here. Yeah.
Yes, yes, yes.
Also, yeah, also.
It's
So
one.
it's 1.
Mhm.
So we need to make, from this expression, we need to make dx the subject of the formula. So you have to multiply, you have to cross multiply, and you are going to have, you are going to remain with, you are going to have dx is equal to, yeah. So this will be our dx. No, no, no. So we are supposed to make du the subject of the formula. Dx is not in, sorry, dx is not in our formula. So when you make du the subject of the formula, you're going to get, this is not supposed to be here actually. So when you make the subject of the formula, du is equal to over x plus 1. So this is our du. We have found our du, we have found our u, we have found our dv. What is remaining is for us to find the v. So you find the d. When finding the v, you integrate this expression. When you integrate this expression, you get v is equal to the power 2 over, is it? Yeah. So when you have reached this, where there you just plug in values where there is u, you have already found the expression for u. You put it on where there is u, the v you put it where there is v, the the v again you put it where there is v, the du you put it where there is du. Then you are done. I think you can finish it, right? Or do we have anyone who is still lost?
Yes, there you are saying we put du dx or dy du.
Where where I was saying du dy dx.
Yes, you
I think I just
mentioned
made, it's supposed to
something
be, yeah,
like
it's supposed to be
making.
du dx. Then you make du the subject of the formula. Yeah, then you plug
Yes,
in
is
into the
it
equation.
all right?
Unfortunately, Doc still has left the meeting.
You can just go to the whiteboard. I have the question.
You have a question?
hmm Integration. Then that kind symbol. Then
Your question is,
inside, I'm saying
repeat,
you write
come again.
the integrate symbol there, and then inside sign cos
Sine,
cos
Cause
4x, 4 to the power 4. No, the 4 is supposed to be
or
the power of cos.
this is the question in the paper. All right. Then to the power 4
Then x dx.
x dx.
Yes, and then they are on the
Yeah,
integral starting from pi over 3 to pi.
pi over 3 to pi.
Yes,
Pi like this.
yes, yes.
Okay, this one is just the same as the first question. What you just integrate by parts, the same expression can work here because these are multiplying. Yeah, these are multiplying. Oh, can integration by parts work here? Can it can it work? Oh, we first try to change into identities. Doc Brighton, how do we change? You can share the screen or we see how we can go. We can use up. Doc Brighton. Okay, Doc Salome. You can. What's the method you wanted to use here?
Sorry, I don't have the question. Where's the question again?
Ah, I don't have the question. Oh, okay.
For me,
Just
I would use substitution.
you would go for use substitution.
Yes.
Okay. Can you try solving? Can you try solving? We see how it goes.
Okay, let me try solving it.
Okay, as she is still trying to solve it out, anyone with a different idea? Not by parts, we need to change. And we need to change. Okay. Also, we use the power reducing identities. Or which identities are we using here?
Like if I say by change, I mean that oh sorry, by not by part, but we change it. Like if we say we what can I say? If I say cos x is cos x squared. Okay, we can say that's to the power 4. We can able to say that cos x squared again cos x squared. And then if we change that one to, we all know that cos x squared, we can change it to 1 minus sine x squared. And then after that, we are going to change that sine x. Well, we are going to let u to be sine x. And then once we solve that u, that u, uh, the u is going to, what can I say? And this may be fear if you have solved it, but if you have solved it already, maybe I can try maybe to solve and then I can share the solution.
Okay, you can solve it while sharing your screen. I don't know if it's possible.
I don't have a board. Let me solve per paper and then I send it. Maybe I don't know if
Okay,
I'm group.
okay, you can solve. Then you're going to share your screen later. I think Doc Sililo, I think you can move as people are still trying to. Or do you have any ideas?
You're saying
I think you can move as people are still trying to solve the question. Or you have any idea on the question on how to go about it. Aha, even wewe na KG minima do KG. Okay, the question is find the critical point of the function of x. State whether the critical point is a local maximum or local minimum. Find the possible values of x for which 2 to the power 2x plus 1 is equal to 3 to the power 2 to the power x minus 1. Find dy dx given that y is equal to anyone. You can just pick any question. Those are the questions on the screen.
I think
I
I go
hope.
with the question.
Ati dokeje. Yes, guys, you can just pick any question and start solving. Yes, docs, I was locked out. Yeah, Dokeji, you were saying something.
Doc Isaac, can you get me?
Yes, I'm able to get you.
Yeah, I've got ideas on the for the is it one, two, the third one.
The
I'm
third
not
one,
sure. Yeah, I'm not sure how to go about it, but I've just got some ideas.
or the one for finding the possible values for of x.
Yes, on that one, I was thinking since we can use laws of indices, like if we've got the same base, we know that when same bases are multiplying, we just add the powers. So we're thinking, uh, since it is saying 2 to the power 2x plus 1, so I was thinking there, they were multiplying 2 to the power 2x times 2. Since the a number without a power, it means it is having a power of 1. So that was my thought there. You can just like yeah. Then I will also go to the other side there. Uh, then we take it the other side. It will be 2 to the power 2x times 2. Then minus 3 times 2 shan equals then plus 1. Then we let 2 to the power 2 2 to the power x equal to n later. Then we find the thing they are looking for.
Um, what about the three? The three that is in the three that is after the equal sign.
As I was saying, like if we let two to the power two like two to the power any or two to the power two x there, like equal to like any data, e.g. b, yeah. Then since the two here is not having, or the two to the power thing will be equal to the any letter, so it will just be m, like it will be m squared then minus 3m, since there's no there's no x there. Okay, let me start by saying this. See, can you use your board? I'll be telling you what to do. Particularly tu aku dengan data pine of audit, so at least do something. Yes, cheers. The question is it 2 to the power 2x plus 1 then equal to, let's open bracket, times 2 to the power x then minus 1. So I was saying, uh, if you've got the same base, we know that if we are multiplying base, the e.g. functions having the same base, we can just add the powers. That's what they did there. Like, and if you've got same base and then they are adding, we just multiply the powers. So in our case there, uh, they were multiplying, so they had to add their powers. So we say 2 to the power x, or 2 to the power 2x times kadoti fifine kadoti pakaza hapo dot multiplied by 2. Yeah, since we know that the 2 is having a power of 1, then equal to that thing there. 3 times 2 to the power x minus 1. Yes, so here I was thinking we can just let we know that okay, uh zoom yako utapanga chemba kono kwa paboard don't be fair should be. So I was thinking we can say 2 to the power x, 2 to the power x, then you put that thing in brackets, then multiply by 2. No, I meant the 2 to the power x, put it in bracket, then multiply by the 2 should be outside. Yes, then squared there. So they multiply by the 2 outside, the whole number there. Yeah. Ehe. Which is equal to shan huko. Then minus 1. Yeah. Then from there, just take those 2 to the other side. I think the one is just alone. The one which you've included in the brackets there is not affected by the 3. Yeah. Yeah. So from there, just take those to the other side. Then from there, we can say let 2x or 2 to the power x equal to any letter, even not okay, I'm going h abasitaseka sana vikempuve language p. Yeah. Then replace whatever we've got 2 the power x with p. So there, since the first part there, we've got the first part, yeah, will be squared. Yeah, so it will be 2p squared. Since we've got the, yeah. Then minus p, 3p. Then plus 1.
Abo.
Now, if you, yeah, okay. Then plus 1 there. Then we know that's a quadratic equation. We can just find the things needed. Yeah. Factors, shan. So what could be the factors there?
2 and
Is it
1.
negative? Okay. So they are all negatives or positive?
All negatives.
Yes. Mhm.
No, the product is 2. 2 times 1 is 2. So having a positive product and a negative sum means we're going to go for negative factors. The factors are minus 1 and plus and minus 1 and minus 2.
So from there, we just say, since we said is it p is equal to 2 to the power x, then replace whatever value you found for is it p, yeah, then we create it to 2 to the power x. So if you let me give an example. If you find values to be like one positive, because you don't say when you are dealing with a quadratic equation, we know that the answers are supposed to be like is it one will be positive and the other one will be negative. So if you find any of our answers to be negative, we only consider a positive answer, since we can't have a negative shine huko. So yeah. So now from there kakosa kwa kasento hapo niko hapa. Let's help one
We
another hapa.
have
So
2 power
okay.
negative 1.
Yeah. So
You express half as 2 power negative
to
1.
the power negative one. Okay. Yes. So our x there will be negative one. Look, what have you done there?
There is p is equals to
Is it
positive 1.
supposed to be one is equal to 2 to the power x? Hmm. So from there, uh, it's supposed to be like x is equal to 0, since a
Yes.
number raised to the power 0 is 1.
Mhm. So just to show something, you express 1 as 2 power 0, and then x.
Oh, okay.
No, you show it as 2 power 0.
Yeah, the bases are supposed to be the same. So, yeah.
Mhm.
So, number point changing 1 to 2, are you supposed to write a statement saying that the bases are supposed to be the same, where you change the 1 to 2?
It depends, but I think you just right. Guys are equal. Why should you
Oh,
need?
okay.
What do you need to explain?
Okay,
We are
okay.
equal.
Okay,
Yeah.
so that was my thought. I don't know if it made sense in Angshan.
Thank you very much, Doc. It makes sense. Uh, anyone with questions regarding what Mr. Brighton was explaining?
Doc, I got locked out. I don't know if you can help me with the solution.
Okay, I'll send them in the group.
Guys, you should be asking questions. For example, talk about question. Come on. Just ask questions. If you ask question, you are not you won't forget is lombangana mekana fezi. Because what happens is this. Umuntu ungaresolve monica simple, but when it comes to when it is your turn, oh, go conjugate a brain more. Okay.
KG. Okay, anyone to help us with the part one and part two, stating the critical point
And
and
where is part one? Part one and B. Part one and
okay,
two.
A.
Okay. You help me with the. Though my network is bad today, hopefully one trip or rest. Yeah. Hopefully. Someone feels attacked. Dog bite of my tachong. Anyway, okay. Doc, you opened me the values. I didn't even check out the values. Okay. Hope you guys can see my screen, ka? Hello?
Yes, Doc,
Yes,
we
I
can see your screen.
Okay, thank you. Okay, so there are two ways of finding the critical points, but that other one I don't like it. The second derivative test. So I'll just use the first derivative test to find the critical points. Y is equal to. Yes, Doc, you can give me the question.
8
Hello?
x 8x minus e to the 2x is e unchangeable.
I want to change my mind. Okay. What else? Consider
That's all, uncle.
that moment when you realize you made a mistake. Yeah, okay.
And I
Hopefully to
realize
work
that
out. Uh, yeah, I was thinking there's no way. I don't love dealing with chi in it. Okay, so I use the first derivative test. So I'm using the symbol y prime. If you want, you can use dy over dx, but still the same thing. Dy over dx must a space. Yeah, so y prime of this x statement will give us 8. It's the same like differentiated them individually to give me 8 minus this one. We can differentiate it channel using the channel, I think so. We hello, this side we're going to have okay, this side we're going to have just 2, then e to the power 2x. You can see that.
Yes, Doc.
Okay, then we equate this to 0. I think I would have just solved the last one. I started changing my mind now. Then we get this one to 0. And to be 0 is equal to 8 minus 2 e 2x. Then the goal will be to find the values of x of this expression. So you can help me finding the value for x. I think that's what Dr. Brighton was doing, isn't it? So then this one will go this side, this become negative 8. Okay, negative 8 is equal to 2e the power 2x. Okay, then we divide both sides by 2. Both sides by 2. We're going to have what? Of negative 4 is equal to
actually, dog. The two is a negative.
which 2 is a negative?
Uh,
Oh,
the yes.
oh, it was negative 2. Yeah, thank you very much for that. I didn't notice. I was wondering why am I having negatives anyhow like this? Thank you very much.
It carries negatives.
Negatives. Thank you very much for that. So basically, we're just going to have 4 this side. So 4 is equal to e to the power 2x. Hope you have followed me up to this far. E to the power 2x. And you should be correct. You knew where I'm going wrong because I'm as blank as you are. I actually thought there is no e. 2 2x. So 2x. Okay. Then from here, it's the issue of just finding the values of x. This x. So how do you find the value of x? We In short, we put in both sides. So to be
That's a
in.
dog.
Okay, dog. I don't know how you pronounce it. LNX, others in. Okay. E to the power 2x.
Okay, just to the yeah, I can't get you, Papa.
Yeah, it seems network has hit.
This one is an identity. It will cancel out this. So
Okay, Gina Mulanda, just talking to yourself. So at least try to refresh
but
your
before I cancel
net.
it out, it's better I take this one. It drops down. This
Oh. I think it's actually logged out now. Dog Isaac, are you still in?
Yes, Doc, I mean.
Okay, Dog KG is out. He has been knocked out by Versus.
Oh, so did he finish the? He hasn't finished the question that he was doing.
I think he hasn't.
He hasn't.
Yeah, he was doing which question? Was it question number 8?
Yes, the one for finding critical points.
Okay, let me try if I'll be able. You correct me. I'm not conversant with this calculus or something.
This calculus.
I'm not conversant.
what time did
Let
I
me
leave
try to.
the screen?
To attempt that. 10 minutes ago, Uncle.
Ah,
You've just been talking to yourself, Uncle.
imagine you guys would have called me or something, guys. You would have called me or something.
Okay, so the Genji, you were somewhere. I think you can just take it up.
I think I left it up to. I found the value of x, which is
No,
lin
he
4.
didn't find the value of x, please.
Or with
He left
myself, I found.
some. No, you haven't explained. You just left it in ln 4 is equals to ln e to the power 2x. From there, I don't
Left
know how
ln
you did it.
4 being equal to 2x, right?
Uh, yes, ln 2. No, it was ln e to the power 2x.
Oh, that one.
Dito ko
Hey,
nakadiro ko sa nagtari.
there is okay. So when you have ln 2, I mean ln e, is it ln e and the 2x there? What that basically means is that this will cancel, right? And then this will drop down up to here. Is
Oh,
it?
okay.
So you're going to have
Exactly.
ln 4 being equal to what's this? Being equal to 2x. Is it? From here, we want to find the, is it? We want to find the value of x, right?
Yes, a lot of it.
So we're going to say ln 4 divided by 2. So our x
Should be
is
then
equal
so.
to ln 4 divided by
Negative.
2. So what this basically means is that our x, how is it? Is it that we we say when x is greater than, you can continue, doc. You can continue. I've lost track of the question.
The question was the question was asking for the is it the critical point?
Oh yeah, the critical point.
Yes, we don't have only found one, so it means don't have one critical point. Yes.
Okay, yeah, it only has one critical point.
Mhm. So it basically just knowing what type of critical point is it? Is it a maximum or
I
minimum?
think I
So
think I think that's where question, I mean part two comes in. It's saying state whether the critical point is the local maximum or minimum.
or it even knew that it was one. Yeah, yeah, so we have solved the first part of when that means just the issue of finding the B part. But
Yeah, whether
the
it's
good part is that
maximum.
they have not asked about increasing or decreasing. That's why that's what just I take out of time. So I think the best thing is though that there are many formulas people use on getting to know if it's a maximum or minimum. Sometimes what people do is sometimes they do take a number that is less than the critical point and the number that is greater than the critical point to find the range for the critical point. If it's going to be if when you get a less than it gives you a negative. If you get a less than it gives you a negative, then if you get a greater than it gives you a positive. Then it means that point is a minimum. But if you take a number that is less than the critical point, it gives you a positive. And if you get a number that is greater than the critical point, it gives you a negative. Then that point is a maximum. Then the point of inflection will give you negative, negative, or positive, positive. So basically, that's the idea that I like using on myself. But there are other ways of using my D, my distance squared case to four. Yeah.
So what do you say? We do the d squared y, is it? Is this even how they write it? What was the derivative that you had found?
We found 8 minus 2 e to the power 2x.
So it was 8 minus 2. Is it 2 or e? E to the
2
power 2.
e,
Or 2e. Okay, 2e.
2 e to the power 2x.
Hmm, okay. How do you even find the the derivative of this? So this would be a 0, right? Will this be a 0 or a 1 to be a 0? And then what will happen to this? Like this will come down here, and this will be a minus 4. Is it? I've
Yes.
actually forgotten how to differentiate this, or is it differentiation or something?
I don't know. He
Will it,
just brought the
will
power
it be
and
something like
multiplied it
this?
by the. Yes, I think so.
Okay. Then what do we do after this? Yes.
Maybe we solve for x again.
So we get this value, right? We plug it in there. Is it? Hello.
Yes, we are here.
Doc, apa so what are we finding hapa? Inapa I'm blank. Sisi unafungwa wafika hapa gafasi la ndio na shine hapa. Sasa gafasi hiyo
We're
direction.
trying to determine whether this point is. Wait a minute. Have we even found the critical point? No, we've only found the x part of the critical point. But anyway, what you can do is that to find the critical point for part A, I mean part one, we have to, after finding this value where we said x will be ln is it ln 4 over 2. Yes. After finding this value, we need to get it and place it in the original equation to find the, as you know, a point. A point needs to have x comma y. So this is just the x part. We need to find the y part. So to find the y part, you just get this same value. You place it in the equation. Then you solve it. You'll be able to find the y value, and then you just put those values together to say x comma y. In short, the x is this, comma the y that you find. And I think that way would fully um, find the critical point. And then the second part requires us to know or to get whether.
Doc, excuse me, Doc.
Yes, please.
You repeat from what you're saying. I didn't get proper.
Okay, so far we found the
Excuse
x
me,
value.
Doc.
Yes, please.
Just just to add on what she has asked, which equation are we plugging this on? Are we plugging it on the derivated equation or the original one which was asked?
On the in the original one to find, that is, in finding the, it's a point. They're saying find the critical point, and you know the way points are. You say x comma y, right? This is more like the way points are, right? Hello. And
Yes.
then
Yes, we're getting.
what we found is the x part. Now I'm saying to complete the equation itself, we need to find the y part. So in finding the y part, what we just need is to replace this same value, the x value that we have already found, in the original equation, which was, is it y is equals to 8 minus 8x, right? 8x minus is it e power 2x? Yeah. So we just get this x value, we replace it in this original formula. Then we put it here, and then that will be our critical point. Then part 2 is asking us to find or to determine whether this point would be the minima or the maximum, the minimum, local minimum, or maximum point. And in doing so, there are several methods that Dockage was saying. Dockage is to in, is out. Okay. And there are several methods that you can use. One method is to um, find the second derivative, of which we've said is this. After finding that, we just get this value of x, to push it in where there is x here. Then we are going to have a certain value that we are going to find. Now the rules are, if that value is positive, then this point is minimum, and if that value is negative, this point is maximum. And then if this value gets to be 0, then the point is uh, indecisively unknown. That would mean you have to use a different method to calculate it. So what you just have to do is, am I still logged in? Mente?
Yes, you are here.
You're still in.
Okay, so in this case, what we just have to do is just to get this value, we push it in here to find the value of the second derivative at this point. Okay, so what do we get if we push it in to this thing? Let's see what we get. So let be, let's say this is just y prime prime will be equal to minus 4. What are we having here? Minus 4 e to the 2x. Forgive my handwriting. I'm writing with a mouse. I don't even know why this is being possible and how this is being possible. Then we have ln 4 over 2. Is this what we should do? I think so.
Yes.
Then we're going to have 2's both sides. We're going to have a 2 here, which can cancel with that one, I guess. Yes. And then we're going to basically have something that is equal to a minus 4 and what's this, e to the ln ln 4, is it?
Yes.
What is e to the ln 4?
1.
It's 1. Huh? Really? Hello?
I don't know, but I'm thinking it's 1.
I've got a question, Doc Sililo. Open up.
Yes, please ask.
Yeah. Uh, according to okay, don't know if it's a question that we should question this when I will wear up. So I was thinking since like those two the E and the Ding they are just inverse of each other. So I was thinking uh the same thing Doc Lomuna said. So those
Mhm.
things will cancel out and isn't for is in the part the four which is up there and the one which is down and they're going to cancel out like since your chili pamura poshan shan and chili pan sharp if you cancel then we have and is it negative one
Oh, this part will result in a 1.
one okay so is
Yes,
it
is it a
going to
1 or
be
assist?
yeah it's
This
one
this is it like this part? This part would be something like, okay, this 4 will come down. Yes, this 4 will come down and then this one will become a 1. I think that's how it works.
oh since the name number is one over that number therefore so okay I've got what you are saying
Yeah. So meaning when this will be a 1 and this will come down, you multiply with 4, and this is what we are having here. It's giving me a minus 16. Unless my retro of mathematics is not very good, but I think this is what it's giving us. And this number, negative 16, is less than 0, right? It's negative, which means our point is what? Is this referring for
Maximum.
point? Exactly, it's maximum. Mhm. Who- Doc, Doc, I'm done.
Ah, Doxililo, just a minute. He has gone.
Okay,
Yes. Here
I'm here.
when I substituted in the original equation,
Mm-hmm.
yes. Can you please write for me 8 ln 4 divided by 2? No, 8 lean 4. Yes, now how do I do that? Your mic is muted, Doc.
Oh, sorry. I was saying you just cancel this, I think, and this, which is going to give you a 4 on top here. Mm.
Yes,
Like
then
4 in.
from there, 4 lean 4.
Okay, so you're going to have.
Oh, is it only me or Doxil has been knocked out as well?
I'm also not able to get him.
Dokeji, you are done with your question. Okay, I think you can continue. Let us do the other part of the questions.
Sorry, my net just blacked out. When did it black out?
Uh, we just wrote 4 lean 4.
Okay. Okay, we just wrote 4 in 4. Then was it? Is it like the complete thing was like we had the minus e to the power 2x? Did we have something like that?
Yes,
uh and what were we doing? Like what
we
were we doing
cancelled.
to do this?
Yes, we cancelled the 2 and the 2 there, which was multiplying the lean 4 over 2. 2 cancelled, and then you said that e to the power lean 4 is the same as bringing the 4 down, which you did there. So on the other side is 4 lean 4 minus 4.
Mm, yeah, I think this is 4 in 4. There's no identity here. I think this is the y part. This is the y part of
Yes,
the, yes. So which means the point itself, if we did everything correctly, would be something like, was it being 4 over 4? I mean over 2, and that is bad. Anyway, but you get the point. Lean 4 over 2 from this G expression right here. Dokeji, you're back. What values did you find? not in. Dr. Isaac, are you still in? Dr. Isaac is not in as well. Okay. Are we ending here or we are proceeding?
We finished the remaining part since we are only remaining with some questions.
We finished the remaining parts. Okay. Is that the feeling of everyone in the meeting currently? Hello? Am I alone in the meeting? The Brighton will proceed if possible because the exam is. Okay. All right. So who can take us with question? What's this? I don't know which question is this, but this part. Find the dy dx of this function or this equation. Y is equals to open brackets x squared plus 1 outside x. Who can take us through this one? Any ideas? What ideas should we use?
Okay, on that one, I was thinking we use that one.
Mm,
Is it? Actually, power room. I think we first start by dropping the x there. Then we multiply by everything. Then
mhm.
we multiply again by the is it to add the derivative of what is inside there.
Mm, okay. You're saying the first thing is that we drop this x here,
Yes, we first start by dropping the x there.
and
Pa
then we
right
do
drop
x minus 1 equal. Mhm.
sunshine.
Then after that,
Then we multiply by is it to add Kashmir could add the by the derivative, but the derivative if there are some what is in the bracket there.
okay, okay. Let's see if it's possible. Hmm.
Now, but how can we find something that has a power of 1 minus 1? Can that be possible to
Uh,
simplify?
maybe, I don't know. Let's try it out. So we're having a y, which is being equal to. Should I use my phone? 2%. Okay, y is equals to, what are the values? X squared plus 1, right?
Yes,
And then outside
the
we're
power
having an
x.
x. So you're saying we first drop this x and then
Yes.
subtract by 1 here. So we're going to have a y prime.
Excuse me.
You are quite excused, madam.
What's the link for the one in the chat box?
Is the link? I'm not sure. What's the link? It's such a long link, like starting with Jamboard, something like Jamboard. Is it?
Yes.
Or is the link to this same board which I'm using, like the link to this board? So
Mm.
I'm not
Oh, okay.
erasing anything. You can just click on that link. You'll still find everything that we've been solving on this board. Previous things. Is it okay? Okay.
Yes.
All right. Oof. Okay. Then we are having y prime as the first thing will be x. After that, we open the brackets, and then we're going to find this as 2x, right? We're going to close the brackets. We're going to say x minus 1. Is this what you
No,
meant,
no, Doc. You've
Doc
forgotten
Brighton?
some value. No, you've forgotten some values. I was saying we first, since we've got
Okay.
yeah, there we've got two functions there. We've got the one in the brackets and the one the power there. So I was saying we first start by dropping the power. When the power drops there, we multiply what is inside there. To finish off, if you don't change anything, then from there, is it? I
What
don't
if
know
when
if
the
it's
power
two.
drops, we do what?
We first start by dropping the power, which is x. So it will be x times x squared plus 1. Then we find the derivative of what is in the brackets there.
Or you're saying when the power drops, we first find the derivative of what is in the brackets?
Okay, Captain, I don't know how to explain, but so I was saying we first we first start by dropping the power. Then
Mm,
after dropping the power, you multiply with what is in the brackets. Everything, don't change anything. Then from there, that's when uh then you multiply
Doc
the
Braden,
derivative. Yes, Doc.
Doc Braden. I
Yes,
was
Doc, I can get
thinking
you.
the only I don't know if I can say a property that can allow us to drop the power is when we are using logs. So there's somewhere where we need to introduce ln or log.
No,
I don't know
you
if
can
I'm not
still
sure.
drop the power.
okay, we're differentiating. Okay, what if we say let u be equal to this? Let's
Oh, we are
say
differentiating. All right, all right.
yes. Let u be equal to what is in the brackets here, right? So this will be like u power x, is it?
Yes.
Then is it? What am I doing right now? So dy dx, okay, dy dx would be equal to,
XU.
okay, what's that formula? I want the formula, like something like a lot of dy dx's again also, like another dy whatever, dy whatever. I'm sure even what that is.
Is it is it
Is it
do I
dy
do
d?
you?
Yeah, something like that. Dy du multiplied by du dx. Something like this. Is it? Yeah. So now we must find dy du. So our dy du in this case, uh, dy du would be equal to what? Won't it be x?
XU.
Um, xu power x minus 1, right?
Yes,
Yes.
Oh,
yes, Doc.
uh-oh, you may find that I'm logged out.
That's still in Doc.
Okay, I was saying, is this correct? I didn't get the feedback.
Yes,
Yes, it
that's the
is.
thing.
Okay, so we found the dy du. Now we need to find the du dx. So let's first write what we should have written already. That statement where we should have said let u be equal to what is in the brackets here. Let's write it. Let's say u is equal to, oh, so u is equals to what was in the bracket, and that was an x squared plus 1, right? So in this case, to find the du dx, we are simply going to say this is actually equal to 2x, is it?
Yes,
Yes.
Doc.
Uh-huh. So after finding this, we just simply multiply this by the whatever, this other thing that we found here. And let's just write this thing nicely while doing the correct replacement. You notice that this is going to be an x, open bracket, the actual u is actually, um, is it x squared? Yes, x squared. Oh, when the mouse misbehaves, handwriting will have to misbehave. So x squared, is it minus or plus? It's plus.
Plus 1.
Plus 1. Then you have an x outside there, less 1. Right? So this is our d whatever, d whatever. And then let me just do things scrappy. We're just going to multiply this by 2x. So our dy dx is going to be, that's to use this thing that we found earlier. Let me see if I can memorize it. X side open bracket, I use this x squared, adding 1, and then that x which is on top, remove a 1 again. But why are we adding 1 inside again? Then we are going to multiply this by a 2x. Is this okay?
Yes.
Yes.
Yeah, then you do your mathematics. What should we even do here? Are you able to do anything?
No, I think you just are you not adding C?
Are we integrating? I haven't done integration, so I've just done I think part of differentiation, and I haven't found where we're doing adding a C. So you confuse me if you say add C. C. Are you
No,
sure?
no, don't add. The thing is only
Hmm.
asking us to differentiate.
The thing is,
The question is only asking us to differentiate.
Unless we are dealing with the integration, you can't add a C at the end.
exactly that's what I thought. I've never found the SC in differentiation. I'm not sure. I think there's having that much of it. So are we able to multiply this 2x by this x which is outside here? Definitely. Right? So can we
No,
have a
I
2?
think
You can just multiply that 2 with the x which is outside because when you start multiplying with what is inside there, 2 are overbalanced.
Yeah, no, we can't multiply with what is inside because what is
Doc should have gone again, Angshan. Because
he
I
has
can't get.
muted himself.
Hello, Doc Still, are you still with us?
yes, I was logged out a bit, and I'm also still hanging at 3G, which means I might get logged out anytime soon again. Yeah. So I think that's how maybe we do it. Are you able to see my screen?
Yes.
Yes.
Okay. Okay. I think we're done with this question. Then the other question is find the integral. I don't even know how you read this thing. How do you even read this thing? Is it find the integral? Oh.
What's
Mm-hmm.
the question?
Um, find the integral. Then there is a fraction x squared plus 3, then x squared minus 1. So some of us would do it the way 12 ways. So, so as the ones are.
Doxy can continue.
No, I'm not sure how to solve this. I'm not sure how to solve this. I'll end up just confusing people. I'm not sure.
You know, I was thinking we
Yeah,
can like cap partial fractions.
yeah, you resolve into partial fractions.
Mm.
Yes. Partial
Partial
fractions.
fractions like this.
Yeah, because
Okay.
it's actually punchable. It's is it a difference of two squares?
Mm-hmm.
So
Okay.
we can say x squared plus 3 over x minus 1, then multiplied by x plus 1.
Mm-hmm. I'm trying to share my screen. I see if it's possible. Mm. Let me just reduce this and 2%. Let me plug it in my charge.
Doxy,
Yes, doc.
yeah, what has happened to, is it Vakedi? Whatever Vakedi, but yeah, Bali kuchara na spin bells.
Not sure what has happened.
Hmm.
Okay. Are you able to get me?
Yes.
Yeah, we can get you.
So you'll be telling me what I have to do. Mm. Resolving into partial fractions. What is even the meaning of
Resolve
that?
into partial fractions. How you're going to do it, we don't know.
To
Yeah.
dissolve it, feel songuru na songuru.
Okay. Let's try and see if it's possible. So what are we having? We're having an x. Let me just remove this. We're having an x squared plus 3, and then per down we're having an x minus 1, and then x plus 1, right?
Equal to
Okay. So this will be equal to what? Is it where we
A
say a
over,
plus b a person?
yeah.
Tell me.
So A over x minus 1 in brackets. Doxid, are you getting me?
Doc Sililo, you are still there.
I think his network is pursuing its green performing. So need to have a masters.
Okay, maybe I can just try to help him out. Doc Burton, you can give him what is on the screen.
Okay, it's on the numerator it's x squared plus 3 x squared plus 3, then divide the x minus 1 in brackets x plus 1, which is equal to a over x minus 1 in bracket. Oh, Okay, then x plus 1.
Okay,
Yeah. Yes.
then we multiply, we
Yeah.
resolve into partial fraction, right? So
Yes.
mainly what we are going to have after manipulating this is 2 is equal to
8 times x plus 1
and then
plus b times x minus 1. Yes. So from there, we can start with n. So if we are like, if you want to start with a, you can say let x equal to negative 1. So that if we place whenever there's x at a there, we have a 0. So we remain with b. So it will be negative. Oh, Doc, Isaac,
oh yeah, so it's
phone
supposed to be
tangira.
x is because already this is going to give us a 0, right?
Yes.
Yes.
Now,
So
you're also supposed to replace there. Yeah.
when we substitute with negative 1
Yes.
like this, right,
Yes.
Yes.
is equal
Eh,
to
it's a 3.
Uh,
negative
yes.
b like this, eh?
Yes. Negative
Negative
2b.
negative 2b, yeah? So
Yes.
this is 1 we get for this side is equal to negative 2b
B.
over negative 2.
Yes.
B is equal to negative 2, right?
Negative 2. Yes,
So
Doc.
this is our B.
Yes.
Then we solve for A
So our A would be 4 is equal
equals
to,
to 2A positive.
yeah, is equal to A. Therefore A is equal to 2.
Mm-hmm.
Yes.
So our our A we got 2, right?
Yes.
Yes. Then
And then
B.
B got negative 2.
Yes.
2x minus 1, is it?
Yes, Doc.
Okay. So when we reach this stage, I think we differ, we integrate, because this has got a power of 1, meaning that when it goes on top, it has got a probability of having a negative 1. So it can't, we can't take it on top to be the numerator. So I can just factor out the 2 and have in x minus 1. Is it, Dr. Brighton?
Yes, Doc.
Minus 2x, oh no, in x plus 1. Yeah,
Just
so
a minute, Doc. Just need clarity on that one.
yes. Which one?
Yes. Do you just there on the lean thing? Do you, in other words, mean that whenever you reach this stage and then you have to integrate, what you do is you say you multiply the value you have gotten on A multiplied by lean the denominator again minus the value then lean denominator. Is that it like every time?
Oh, okay. What is here is this. Um, you don't say that the calculating one of x over x.
Should, my question
in
is,
a,
should it always be like this?
It
yeah,
depends,
what
Doc.
you when question there to yes, in the thing x as what you do, you first out to the two be the one over x plus when we integrate but in one, then you multiply with the two.
Doc Isaac, I don't know if it's just me, but on my part you are breaking. Okay, to help Doc Lumno there, it just depends with the values that you have. For example, in our case there, if we had 2 over the x plus 1. So what Doc Isaac was trying to say was we just factorize the 2 there. Then we know that any number, like any number, for example, we've got a 1 dividing any number. That simply means that's linear. Fast lean. So if we had if the 2 wasn't there on the numerator, we would have just said, we would have just taken the denominator to be the numerator, then the power -1, then we integrate there.
It
Right.
seems to be breaking.
Doc Lumino, are you clear now?
I don't know, but what I heard is you said that if if there are different values that we are given, then
Okay,
you
okay.
can
The
work it
main
out
goal
like
for
a
us is to
binomial.
have a one in the numerator.
Yes, Doc, continue. You're getting you. Is out. Doc Lumino, you are saying what?
Yes, I was saying that what I got from your explanation so far is that when the numerators are the same, you solve them like a binomial where you put the denominator on top and then it becomes a negative.
The
Is
power.
that so? Yes. So now, what is so special about this thing? Like, when should I use a lean and when shouldn't I use it?
Okay, the main thing there is we are introducing a link there for us to like integrate easily, because there's no way you can integrate something like something which is dividing another thing. You can get lost. So our thing there, our main idea there was to have a one dividing those things that were on the denominator, so that if we take so that it will be easy for us to integrate. I don't know if you've gotten what I'm trying to say.
Yeah, one more other thing is look at this because when you yeah when you have let's say 1 over x plus 1, right? So this has the power of 1. When this, okay, let me just use this example, x. This has the power of 1. When this goes on top, it is going to be x to the power -1, right? So when you, according to the rules of integrating, you have to add a 1 there, and then you divide it by the -1 plus 1, which this is going to give you 0. When you manipulate this, is going to give you 0. And then you know to say, we have been learning to say that when you are dealing with functions, we always avoid to have a 0 in the denominator. So the reason why we have come up with the ln.
All right. Thank
Yeah,
you.
so whenever there is something that has a power of 1 in the denominator, always just add in. a lot of people disappeared. I think that's all for
Yes,
today.
thank you.
You can give us a prayer, we go. We started with a prayer, we just can't leave the meeting.
All right, shall we pray? Our dear Heavenly Father, we want to say thank you for being with us, guiding us, and for protecting us. We pray, Jehovah Lord, that whatever we have learned today, Father, help us not to forget, and help us, Jehovah Lord, to always be able to apply the knowledge that we learn each and every single day. Amen.
Amen.
Guys, muchoka.